working? Not quite sure. Well, it'll work well enough. Oh, that's what we're all about here. Is, well enough. No, no, never settle. Anyway. Good morning, everybody. It's Alex. This is the day numbers are made up, by the way. Day 20 of at least the stream of making escape velocity. I work a lot more on off stream. Oh, hey, that's Squash. Good morning, Bunny. Good morning, Bunny. You wanted to join us? Well, if you'd like to join us too as we go get started with some nice, fun game development today, all you need is your drink of choice. Mine today, oh, she's gone. Mine today is some nice, beautiful Chou Pu'er, aged from 2012. So this is quite the vintage. I'm down to like my last three servings of this pu'er cake. It's been good. It's been good, but like with it's just too good of a tea. And in cake form, I simply just do not want to bring it to work and check it in my regular thing. But anyway, whatever. Let's have our sip. Okay. Okie dokie. I have to do all this crap every time. So I made some pretty good progress last night in fixing some of the coordinate system mismatch. So if you look here, actually everything is now right side up. It's all right side up. We're drawing text with the correct not only baselining but kerning, which is really awesome. And we have spilled that all over myself. We have removed a bunch of extra steps in our rendering loop that we weren't using. So I'm super happy with the result of that. I'm not happy with how my mic is mounted. That like constantly is creeping me out. But it's unfortunately a must do. Um so yeah, no, this is awesome. We're really unfortunately not done yet, but we're pretty close. So check this out. Here is our uh current problem. And actually have we have two. Okay, no, actually number two is fine. So I was looking, I'm never actually passing like a size correctly into the font rendering. Um, so this is like the screen space rendered font we did. Um, and I'm pretty sure what's happening is the bitmaps were baked at 32 pixel height for per character, right? So we just picked arbitrarily, and that is about how big they should be. That's about the 32 pixels right here in screen space. But if you look at this is one we're trying to draw in world space on top of our spaceship friend here. That is really small, right? And I think it's purely just because we are doing some camera scaling. I think it's purely just because it's going through the camera scaling as part of the end projection matrix, right? And so because of that, it's that this the quad that's in here is getting having this projection that shrinks it down on top of it. So I'm actually not worried about that, having just thought about it for more than 0 seconds. But the thing I am worried about is this up here. So this question mark, and this is a real worrying one. This question mark actually is supposed to read out the exact same text as this line here. this is a hard-coded line of just like what would our normal values are, sorry, what are typical values for um the pieces of our spaceship momentum here. So like a momentum X, momentum Y. Um, Also they were typed on a very specific part of the keyboard by mashing. So don't worry about it. But this right here is supposed to be the exact same line, but run through the my sprint s string formatter. Uh, and so the result of that should be, the base string is like 2% Fs, right? And then the format that's passed into it is the momentum components in X and Y. So that, what that should do, and actually right now it's even hard coded where it's just literally passing in this value and this value. What we should see is that exact same thing duplicated down here. Exact same thing. And that's to test out the path of, is there something stupid with like this specific series of glyphs? No, there's not. Is it, is there something wrong with the positioning or spacing of like how we're putting the glyphs on the screen? No, there's not. Um, and the problem actually is even more insidious because if you look here at the output, we are logging um we are logging the current momentum of the spaceship every frame, right? Um, and that is happening with the same thing where we're also using a sprint s here. Um, we're using the exact same function call and passing it in the same way right here. And it actually is good. And I'm actually duplicating that down here basically. Um, so when we pass it in to sprint s, like right before, like right here, if we look at the watch window, it's good. It's actually good. And now the thing kind of did a little bit more than we wanted it to, where it actually added some padding zeros here to make these equal on both sides, which I will not really consider a bug for purposes of this testing because that is probably intended behavior from the VSN printf. Um, but follow me as I show you as we look down a path of most curiousness. Okay, not in there. So just keep an eye on this text uh, watch as we step through. So we go through get a current char, right? We get we go just do a check to make sure it's not like a meta character, okay? And then we go we have a draw, we have a queue. We set all the data in the new quad, and then as soon as we go to this line, oh sorry, as soon as we go like so, now the data in here, and if we look at the memory of it, it's now been corrupted, right? The actual data is gone. The count is still here. This was the count. Um, but it's drawing the glyph of the first character, sending that into draw quad right here. Oh, whoa, whoa, what's going on? Um, yeah, let's redo that. Um, but as soon as it goes in there, somehow that chunk of memory goes away. So if we look right now, actually this is the wrong one. Uh, let's just get rid of that one actually. Um, Yeah, we don't want this one. That one will not tell us anything more useful at this point. Um, okay. So here, this is the one where it's like good. This is the hard-coded string. And it's got to draw a bunch of quads. And then we go in here, right? And we have this is F string is the formatted one that was done by hand. Okay. So, and look, the data for it is still correct right here. And if we send that to the memory window, we can see it. We can see, oh, actually, so we can see the 17 right here. We can actually see, maybe last time it dumped that value. There's like a couple of extra like garbage ones hanging out. So here is text.data is this right here. And I do want to preview it as these are int 8s. Whether you int 8s. Um so the data is right there. Yes. We look, we go in here, and then we go in here. Yeah. So we set all the quad values. We cull whichever we cull if it's outside the box, outside the screen. Then this actually goes and gets injected in. And at this point it's bad. I think we should just watch the watch window because I cannot I don't know why it's going away there. It's really confusing. Um and that's why I thought maybe it's like we pushed it off the stack somehow. Because like we go through all of this, we shouldn't be touching that part of memory. I don't think. Um and this is like the only spot where we're actually passing in by reference something is this. Um this is like the quad of the first character, which is getting we're picking the glyph of that correctly, the glyph texture, and you would see it's that there's like a negative sign. It's rendering that first character, and then the rest turns to garbage. So we go out here, 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 and then we're at the end of this one, and then this memory is just like totally hosed now. So I don't understand. Um, that's why my comment here is it pushing it off the stack? Um, because I don't know. I don't know what happened to this thing. Because that certainly does not look like that does not look like uh our string at all, right? If we look for text.count, text.count still exists actually. It's right there. So I'm very confused. I'm very confused here as to why we're seeing what we're seeing. And I thought I had the idea, is this some sort of um char width problem we're experiencing? Is this a problem where like VSN printf is like we're putting everything in as U8 chars, and this is returning like 16 bits somehow? And the answer is I don't think so. 'Cause it's just using the char type, which should be a 1 byte. It should be a 1 byte type. I'm pretty sure. Um, and like again, we're formatting this string. Uh, we are formatting this string, and the result is making its way into memory in some way that we want. So if we get rid of everything else, oops, I don't want anything else confusing us or rendering something or doing whatever stupid thing. We will even get rid of this. We've purely isolated the problem down to somehow, or for some reason, the sprint s formatted string is not it's not renderable. Oh, whoops. Okay. So if we look right here, oh, that's still logging those out. Oh, whatever. I don't care. That's fine. Um. Okay, so boom. Now it's good. And these strings are are on the stack, right? The data for this string is on the stack. But this, I don't know, like how big is the stack? How big is the stack? Come on. How big is the stack? Hmm. So a couple of kilobit, couple kilobyte, 1 megabyte there. But really, like, how is that possible that we are using up a megabyte on the stack? And it's like just hitting that point there. I don't buy that. I don't buy that. But I mean, like this is some kind of memory allocator problem. It's very much looking like, right? So if we look at the memory window here, um, I want to see fstring dot data. This is like unreadable, unfortunately. Can we see this? No. All right, so I'm gonna just have to take its word for it that this is. That doesn't look like the. It never looks like the same freaking thing. Um. Unsigned char star. Oh, here we go. Okay, here we go. This is the chunk of memory we want. This is the chunk of memory we want. Okay, I think we've just been looking at the pointer. I'm fairly certain. Okay. Um. All right. Cool. So let's go in, and now maybe we can find it. Now maybe we can find what the hell is going on. Oh, oh my God. Yeah. So there it is going in here. Going in here, um, must be using this same part of memory for some reason, and it just totally hoses us. And now I can't even find it. It's just gone. Um, it. Why? I mean, is it? I kind of want to understand like what I did wrong here. Like, did I page this out of memory or something? Because this matrix is it's not that big, right? It's just like 16 floats. Oh look. Oh look at that. That is maybe the second half of it right there. Yeah, that's the second half of the value. So it blew up that whole first piece. Oh, and then look at this. This is also like the formatted one. Hmm. Someone did something creepy with my memory. Someone did something awful. All right, so if we look, we're at this instruction right here. So is there anything, or we think if we step into draw quad, And then we step into this M4 multiply. We think that will be over our EFEB 80 memory somehow. I don't think we need to look at the instructions. Um, EFEB 60 to move. So this RSP, whatever that is supposed to be, pointer, RAX. It seemed, yeah, like this is definitely the same as this chunk of memory, right? So maybe what we happened is we ran out of registers. Um, I fuck, did we really run out of registers to? Because like, why should RSP be in there at all? Because that's totally it. That's RSP plus plus 2O is this chunk of memory right here. So, but I can't understand why why it did that. Because what is this? I'm pretty sure this is the instruction, right? RAX 5AE. Ah, I mean, oh yeah, I don't know. I don't know what this is. Um, Crap. Oh, that sucks. I mean, so I think regardless of what exactly like, because as I think we may actually have ran into like a C compiler bug. I think like I think that's where we are, because again, nothing's trying to touch that chunk of memory. Nothing I typed should be trying to touch that memory of this string. Um, and all right, so if we look right here, what instruction is going to break it? It should be this very next one where, oh, actually, no. What is LEA? LEA is LEA is less than load effective address. Ah, used to calculate the address of a memory operator without actually accessing the memory. Also perform arithmetic. I would like to see what this all means here. I'm going to um get some more tea. Some more tea really quick. The stack frame is very small. Hmm. 664 bytes. Yeah. Which is this function. Uh, yeah. Yeah. Before the rep moves B, you stop on that, nothing's copied there. RSP plus 20 is relative. Yes. Yeah, I mean, it's going to be, we need to be more carefully managing the string memory allocation is the real result here. But like frick, like I just want to understand. Yeah, I'm pretty sure I got it right that like the thing is on the stack. Um, the thing is on the stack and it is getting pushed off by by this matrix multiply. Oh man. Wow, ah what a bug. And yeah, crap. Yeah. Wow. Wow. I cannot believe it. I cannot believe what a way to start the day. We actually we actually corrupted the stack. I'm not just smoking crack over here. There was actually the correct assumption that that call. All right, so we should be able to see it. Um, where's RSP? RSP. So it's a couple down here. So I think this right here will corrupt or string data. And there it is. Because we're loading the new matrix or we're loading something onto the stack. It could just be also the 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 address of the M4 multiply function. I don't really. It doesn't really matter, but that's the bug. Fuck man, you wouldn't see. You come on this channel to see this type of content, not for not for any JavaScript stuff. We're doing some real programming here. Okay. Oh God. All right. So what do we need to do? I think Um, I think what needs to happen again is that these strings need to be allocated in memory a little bit more sanely. Um, and we have something for that. You know, we have like a temporary allocator. Uh, yeah, because this is all on the stack. Um, and I thought that would just be fine to do that. God, I hate strings. Drive me insane. Off a freaking wall. Um, so okay, well, let's also stop and think for a second. What else are we allocating on the stack that is in danger of getting pushed off and corrupted like this? Um, I think thankfully most of the things we have are in are correctly in our memory arenas, right? Or if they're not, they don't really matter, right? So we're creating like a entity here, and then we, you know, but actually, we are, yeah, this is just finding a pointer into our existing memory that we've created, and then we're just changing it all by reference. Okay, so that's fine. That's fine. That is supposedly getting heap allocated right there, and that's fine. Yeah, we're doing all of we're at least grabbing enough room, and we're dumping all of these things into the heap. So I guess what we could be doing, we have this transient storage, 1 megabyte of transient storage. I could I could put it there. Um, so that goes all the way down to like the Win32. Yeah, so this will actually alloc. Um, so we don't need to do that. Oh, actually, where's like the get temporary one? I think there's something wrong in here, or I don't think like there's an actual temp allocator that does anything useful. But that's okay. Um, mm, mm, mm. Okay, I'm kind of not concerned. I think everything like in game land here, except for like these strings, uh, probably is those are probably all fine if they only need to live for like one one line here. Um, because well, like all right, so there is still a danger of like crap like this getting pushed off the stack if we're running low, then like if this is doing any like temporary allocating of stuff, and it is, right? It goes and grabs um a big char array. But I think the compiler would tell it not to break that because we're not going in. The only function after that we're going into here that should be overwriting this any memory is this VSM printf, and we are passing it the full like context of full context. We're passing it in like both addresses basically of the things we wanted to keep. So I would think that that actually is just fine. I would think the compiler is smart enough to see that um and not tell it create assembly that's going to overwrite that crap. That's my assumption. Um, all right, and then what other junk are we doing? This is all heap allocated. All of everything that ends up in an entity field is heap allocated, so we don't have to worry about that, which is good. Um, yeah, like crap like this also is like is living for such a short period of time. Um, yeah, it has to live like to here, so that's probably okay. Uh yeah, I think we just found I think the bug really is with here of like having to go into that projection. Um yeah, once we have to go into that projection and grab the thing, there's just not enough space. Oh, that is so annoying. That is so annoying. Um crap. All right. And this is why we do this, ladies and gentlemen, is to it's trial by fire. Uh, I just want to see. Is there anywhere else where I'm doing something like horribly stupid? You know what? I guess I could just. Uh, yeah, cause man, I think, and this is the problem. Like I knew this memory model was like a little half baked here. I did not realize at what point we would be the ones baking is the issue. Um, yeah, so we confirmed that. That's confirmed. Um, so all of this crap here is not really gonna help us. One second, gotta take a phone call. Sorry for that. Had to do a little side quest there. Um, all right. So where are we here? Yeah, I just want to make sure. I want to see anywhere else where we could have a like stupid bug like this. Um, the places where I'm like really worried about it. I'm actually not here. I think over in this land we're not going to really need to. Hmm, it's hard, and that's exactly why the compiler didn't see it. Is like once you go, because you're looking for bugs, you're you're looking for bugs that are going to only present themselves like nested like four function calls in, right? And if something happens to take up that much, all right, I think that's kind of a not good exercise. So let's see. So how can we fix this, or how can we prove that this will fix it? So I can um, or you know what? Actually, if we look in here, uh, if I look in here, we are passing in the string, the text string. Um, we can do just really stupidly is like do the convert to null. It's like, and then here we can do the alloc. we we take in this the source string and oh god, this is pretty bad too. But I just want to crank this out just to make sure, see if we can get something working. Oh, oops. Okay. Um, um, yes, because Sean's thing overwrites these positions, which is very annoying. So we had to copy it. Um, okay. So we do that. Then that well, let's see. Let's see. So we've got text, and then we want to see current char. Current char right there. Cool. Cool, cool, cool. So we go. Oh, crap. Let's go back. All right. So current char. Cool, cool, cool. Um, and let's look at the let's send that to the memory window. And then we will go in here because this should be a copy of yeah, it's on the temporary allocator. So you can see actually like this, our that we have the path of some of the sprite sheet and the font sheet. So this is like other stuff we've used it for. Oh, and actually look here. This is when I was testing out to make sure we could do all the glyphs correctly, and that's still that's still like in memory somewhere. That's kind of funny. Anyway, we're right here, right there. So we want to I think now this should be good. I think if we go out here, in here, out there, now that memory should be protected. Oh, awesome. Awesome. And now this will leak. Um, that will leak. So we need to fix that. Um, yeah, that's definitely going to cause a problem. Oh, look. Oh, actually, there's just a handy Alex string over here. We should do that. We should do that instead. So, string s, string count. But then how do I get the data in there? Oh God, this sucks. Okay, so string, string, keep string. This is pretty degenerate here. Alex string. We'll do the get query allocator. Uh, f string dot count. Not in. No STDs here. Um. Okay, and then this one we pass in, and then we can de-Alex string. Da, da. How about that? That's pretty awful looking, but I think it will be a little less awful than what we were doing, maybe. Because here now, this pointer should be heap allocated, right? So it should not uh get hmm 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 Sing it to me. Don't see anything. Oh, wait a second. Oh shit. Oh. Ah! uh, okay, you know what? Let's keep that local. Let's keep that localized to here. Uh, oh, come on. Undo tree broke. So lame. So I want yeah, because I think if we do it locally, then there's like far less risk of doing something abominable. And then just at the end, we need to yeah. No. Yeah. And then out here, we don't need to do that. We don't need to do that anymore. All right, so we're still. Oh. Um. All right. Fine. So we're still, copying this stupid string around like way too many times. But at least now. Yeah. Yeah. Beautiful, beautiful. Oh no. Oh no. Oh no, it's still leaking. Oh crap. Oh god. Oh no. But why? Why? Oh shoot. All right, that calls for some more tea. I mean 16 seconds here. Okay. All right, we got the tea. So clearly, something is wrong here. Location FFFF. So why did this? Oh, yeah. That kind of looks like this like three blah blah blah. Now that does look like our pattern here, doesn't it? That does look like the pattern of the thing. So we change this to um do one of those dead foods, you know. Okay, and we let that sit for a second here. We let that stew. Let's see. La 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 di da. La la la. Waiting for it to crash. So how are you guys doing? Having a good day so far? I certainly am. Okay, there we go. So let's see. I'm gonna guess dead food. Oh, I suppose not. I suppose not. Is this? Oh well, maybe um hex display. Hmm. Oh, you know what? Because I'm stupid. I passed in the character. That's not how you're supposed to debug memory, idiot. So dumb. Valid suffix OOD on integer. Are you kidding me? I cannot just type that. Are you serious? Come on, bro. Oh, so stupid. See, just trying to print out some silly numbers. Oh, because I'm stupid. Oh, yeah, that's the wrong ooze. Whoopsies. Okay, there we go. There we go. Now this should give us some bad food indeed. Dead food. Dead food. How do I make those capital? I guess I have to capital X them. That's okay. We can live with it. Um, all right, we are running out of time here, but I think this is pretty good progress though. Still, okay. So here's our crash, and now we expect in the memory to see some dead foods. Oh no! What the hell? Hmm. 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 RAX. It kind of sucks you can't. So that is RAX there. RAX. It has is this immediate context business. Um. Hmm. Yeah, I mean we know what's going on, right? But it would be good to. But why is this dialect not working? Um. Oh, cause I'm D. Oh my God, that's the wrong. That's I forgot to delete that. Oh crap, that would do it. That would do it so quickly. That would do it so fast. Oh my God. All right. Okay, that's good. Well, that was a little scary there for a second. All right, we will let that percolate. Well, we will let that percolate. Hmm. In fact, I will go get some more tea. Aw, crud. I guess not. Um, what are we looking at here? Yeah, still like so much junk. Shoot. I definitely rebuilt, right? I may not have rebuilt. Hmm. Hmm. It is interesting actually that the catch is always right here, right? Because this is, well, I mean it makes sense, right? So because this is the very first call in the render loop, so it is going to be like the very first thing that happens basically after, because that like string printing crap is like right at the end of the game state loop. So it would be like right here, like after we corrupt the all the memory that we get a problem. I would guess. I would assume. Um hmm. Oh, tricky, tricky. Tricky, tricky indeed. Um all right, if I still kind of want to just make this as obvious as possible. Yeah, because like it's literally like the next line of code that's gonna get run that really does anything. Because oh yeah, because there's an alloc right here for the clear color. Um, Probably this one. I mean, this one's not really doing anything. Yeah. Oh, I guess it is reallocating the back buffer. Uh, hmm. You know what? Like, man, maybe I shouldn't be doing that. Where do global variables get allocated in C++? Are they heap allocated in the executables data sections? What the hell is that? What is the executables data section? Ah, interesting. Never heard of this before. Hmm. Hmm. And it knows how to do like string literals like that. Oh, gee willikers. Hmm. Mem is not on the stack. Oh, interesting. Yeah, this is not. All right, so that we don't care. But that's interesting. This is well because these are whoa. Hold the fort here. This has a bunch of pointers to the things though. So these at really are getting heap allocated. That is not a problem. Um, yes, these are all getting heap allocated correctly. But then this the handle to it is up there. So actually, and I don't know, like, will anything ever corrupt that data block? Hope not. That would suck. That would suck major time. Um, yeah. Okay, so all right, so we're doing all that nonsense. We're coming in here. We're doing a temporary allocator of this thing. And you know what? Like, honestly, let's just keep allocated. It's gonna be slow, but my God, this is like really, this really stinks, right? Allocator.data. E. There is potentially a bug in the allocator code too, which would be bad because that would require a science experiment to rewrite. Let's let this. Uh-oh, what the fuck did I do? I tried putting in 6969 in there, and it formatted it a way I didn't expect. Okay, whatever. That doesn't look like a um. That doesn't look like we're corrupting the memory. It just looks like skill issue. All right, so I'll let this go run for a bit here, and then unfortunately, this is probably going to be our last little one of our last tries here before we gotta be done. Gotta go start work for the day. Start work for the day. Work for the man. The man, I call him Sir. All right, that calls for more tea. It hasn't crashed yet, so that's good. Yeah, this does seem like it has been running for a lot longer than the other ones did. Um, I guess I will leave that, and I will have to leave all of you beautiful people here with that closing statement for today. So let's commit that. Git commit -am fixed stack corruption. Um, not 100% sure. Um, not leaking. Okay. Which I think is just the way memory leak works. If we can maybe look like is it just increasing? Where's our main? So this is at 76.9. I think that's usually what it's at. And if it's moving very slowly. All right, I'm gonna let that run for a while. Thank you for watching. Thank you for joining me on this most fun of streams here today. I feel like as of this very moment, I am a true C programmer. Having caused a stack corruption bug in all my many years of programming in C. This is, I think, the very first time I've done that. So that was pretty cool. So thank you very much for watching. I hope that you have a wonderful rest of your day. Keep programming, keep coding, doing things the fun way, and I'll catch you guys all next week. Actually, maybe